Okay, so let's start. Welcome everyone to our 7th RSV Patient Network webinar for parents and general public. Happy to see that you have joined our webinar today, and our goal with this webinar is to provide parents and also everybody, general public, who is interested in RSV, more information about the virus, and also to inform you about the developments that are ongoing to prevent or treat the RSV infection. As always, Dr. Lieke, the Frankrijker pediatrician specialized in infectious diseases at University Medical Center Utrecht in the Netherlands, will give the presentation. And today we will focus on how the virus is spreading, and the title is RSV Travels by Airplane. So keep in mind that there is a live translation available in different languages, so you can easily follow the presentation given by Dr. Lieke in your own language. Below in your screen, you can see the globe icon. If you click on that, you can choose your preferred language. After the presentation, there is room for discussion. You can use the Q&A or the chat box to write down and ask any questions that you have. This can be in English, and if it's difficult for you, you can also try it in your own language. You can also raise your hand, so by clicking on the hand to ask a question, and then we can unmute your microphone to say loud what you want to ask us. And please, it would be great during the Q&A just to turn on your cameras when we are talking. After the webinar, an evaluation form will appear, and we will be very happy to receive your feedback. We want to improve, so any feedback is welcome, and also suggestions. So now I stop here and I give the floor to Dr. Lieke. Lieke, please go ahead.
Thanks very much, Leila, for the introduction. I will share my presentation with you in a bit. So welcome everyone. I'm very excited about this new webinar, and I'm very thrilled that you've joined us. Today, the title of this webinar will be RSV Travels by Airplane, and I will explain to you later why we've chosen that title. First, an overview of what we'll discuss today. In the first part of the webinar, I will give some general information on RSV infections. Maybe some of you who have seen this webinar before will be familiar with that part of the webinar, but otherwise, I'm hoping it will give everybody a chance to start out on the same page. And in the second part, we will talk about RSV transmission. Like Leila said, we will talk about what researchers have learned on the spread of RSV. And we will also talk about what factors play a role in the spread of RSV around the world. And then the final part will be a Q&A session. Like Leila already said, I do encourage you to ask your questions during the Q&A. So should any questions arise during my talk, please feel free to write them down or to ask them during the Q&A. But first, let me introduce myself a little bit more. So my name is Dr. Lieke. I'm a pediatrician specializing in infectious diseases, and I work at a large children's hospital in Utrecht in the Netherlands. It's called the Wilhelmina Children's Hospital. I did research when I was doing my PhD on bacterial viral interaction with RSV. Other than being a doctor, I am also a mother. This is a picture of my twins, Seth and Jonas. They were born prematurely at 34 weeks, but now they're already 5.5 years old. And as you can see, we all very much love ice cream. So, like I promised, I will start off with the general introduction about RSV. So what is RSV? It stands for respiratory syncytial virus. It is a highly contagious virus that affects the airways. And when we talk about the airways, we mean the nose, the throat, and the lungs. I'm going to talk about the spread of RSV on a global level today. But first, I will talk to you about how RSV spreads from person to person. How do we get infected? Well, first of all, it's highly contagious. And the spread of RSV is through droplets. And droplets are produced when a person, for instance, sneezes or coughs, or even when they speak. The virus can remain on surfaces such as countertops or doorknobs, but also on hands or clothing. And so you can imagine it's very easy for the virus to spread when, for instance, a person touches something that is contaminated. It's not surprising that RSV can spread rapidly through, for instance, schools or childcare centers. But how does the virus infect the airways? In these pictures, you will see what happens. So first, RSV enters the airways through the nose or the mouth, and then it will attach to the cells on the surface of the airways. Once it's attached, it will enter the cell, and inside the cell, the virus is going to replicate. And this will lead to the disappearance of the cell walls, and we call this syncytia formation. The infected cells will eventually be destroyed by the body's immune system, and the infection will lead to swelling of the airways and more mucus. The airways will thus become very narrow, and you can imagine that the airways of, for instance, young children are still very small, and thus a little bit of swelling or a little bit of slime will lead to more extensive narrowing compared to adults. Once there is narrowing, it is more difficult for the air to reach the airways, and this might lead to difficulty breathing. When the infection with the RSV virus has reached the lower, smallest airways, we call it bronchiolitis. But what are the symptoms? Well, the symptoms of RSV can vary greatly. So in adults, the symptoms might just be those of a common cold, for instance, a runny nose or a sore throat. But in older adults, especially those over the age of 60 years, the symptoms could more easily lead to, for instance, difficulty breathing, more coughing. And this is especially the case for those with an underlying disease. I will touch on that subject again later. For children, the symptoms might also vary. So some kids might just have a runny nose or a sore throat. They might have some coughing or a bit wheezing, which is like, a wheezing sound that they make once they're breathing. Some children might also have a fever. We will see more severe symptoms in infants. So babies with RSV might have very aspecific symptoms. For instance, they might be more tired, act a bit fuzzy, or be cranky. They might also be less hungry than usual or have difficulty feeding. And sometimes they might experience difficulty breathing. I can show you in the next slide what that looks like. Sometimes the virus can also lead to breathing pauses. We call that apnea. So like I promised, I will show you what it looks like when these young babies or infants have a severe RSV infection, because then they might have difficulty breathing. So it's important to know what to look for when this happens. We're going to take a look at this video, and then we'll talk about what we've seen. So please take some time to take in what you see and maybe what you hear. The sounds are not very loud. And then we can reflect on what we've seen.
Hey.
So did you notice the signs and the symptoms in this baby? So I think you might have seen that the breathing is way faster than normal. And also when the child is breathing, the skin is pulling in with every breath. You can see this most markedly between the ribs. You might also see some intense coughing. We didn't see this, but sometimes you could hear the noises while they were breathing. In some young babies, you can see head bobbing, which means their head is going up and down with every breath. And this is a sign of difficulty breathing, because then the babies are using additional muscles to help them breathe. Sometimes when it's severe, their skin color can become gray or mottled or even blue. And you can look for these skin color changes in the fingernail beds or in their lips. If any of these signs are visible, or when you're in doubt about whether or not there are breathing difficulties with the baby, it is important to immediately see a professional. So how about these RSV outbreaks? When do they occur? Maybe you've heard about the seasonality of most RSV outbreaks. So in temperate climates, RSV infections usually occur during the late autumn all the way through early spring. In tropical climates, it's a bit different. So mostly the outbreaks might occur during the rainy seasons, or sometimes even year-round without any specific outbreaks. It is also quite interesting to see that after the COVID-19 pandemic, the pattern of virus infections changed. In many countries, RSV has been absent for a long time, after which it returned when the pandemic measures were lifted, leading to very large and uncharacteristic outbreaks of RSV, also out of season. I think it has only been since last year that we are starting to see a more normal pattern. So it had a huge impact, the COVID-19 pandemic. But what are the risk factors for getting infected with RSV? For children, it is being born around the start of the RSV season and going to daycare. You can imagine with what I just told you about the spread of the virus in, for instance, a daycare center, that the risk of getting infected there is high. And for adults, it is coming into contact with young children that offers a risk. But what are the risk factors of becoming severely ill with RSV? Several patients are at an increased risk. For children, those are kids under 6 months of age, or when they were born prematurely or have underlying heart-lung disease. It can be up to 1 year of age that they are still at increased risk of severe illness. Also, children with a weakened immune system, for instance, children who have had an organ transplant or who have an immune deficiency, or who have had, for instance, chemotherapy, which weakens their immune system. Also, children with Down syndrome or neuromuscular disease, because they are less strong, less able to cough up any slime when they become infected. For adults, the risk factors are comparable. So I already mentioned those over 60 years of age are at risk of a severe RSV infection, but also those with heart or lung disease, similarly to children. And also those with a weak immune system are at increased risk, which is also, for instance, chemotherapy for cancer or an organ transplant. It is very sad to say that the burden of RSV worldwide is tremendous. It's huge. So every year, around 34 million children under the age of 5 years become infected. This means 1 child every second. And very sadly, death due to RSV is highly dependent on the setting where a child lives. So we know that in high-income countries, mortality is very low. It is below 1%. Whereas in low-income countries, it might be up to 10%, which is, of course, devastating. Like I told you before, young children are at a very high risk of getting RSV, and we know that by the age of 2 years, all children will have had RSV at least once. So I told you in the previous slide that the burden of RSV is high, but not all children will become ill. And in this reverse triangle, you can see, although 100% of all children under the age of 2 will become infected, only about 10% will get an RSV lung infection. So with most children, it will only lead to an infection of the upper airways. Only 2% of the children will need to become hospitalized. So they have such severe lung infection that they need, for instance, extra oxygen or help in feeding. And only 0.1% will need intensive care, which means they need help with breathing. How about RSV in older adults? We know more and more about RSV in older adults. And in 2015, around 1.5 million episodes of RSV infection were reported in high-income countries. And it is thought that around 15% of those episodes actually led to a hospital admission. So that's quite high. In fact, researchers even think that the burden of RSV might be at least as severe as that of influenza. An estimate that was done on reported data reports around 336,000 hospital admissions for older adults with RSV infection every year. That would be 1 every 2 minutes. It's also a very important virus for older adults. There is still no treatment for RSV infections, so supportive care is important and is the only thing that we have for those patients. So in order to support the patients, we usually hospitalize them. So it means they are admitted to the hospital, they receive oxygen support, and sometimes even support in breathing, like I told you, when they have to go to the intensive care unit. And also, especially in infants, they might need tube feeding or fluids through a vein. Luckily, there are several strategies for preventing RSV. So there are 3 strategies in order to do this. And the first one is antibodies for babies. We have had an antibody for a long time, but recently a new antibody has been approved, which is effective in also healthy newborns by just giving 1 dose, which is different from the other antibody that we used to have. Because that other antibody needed to be administered every month, and it was very, very expensive, so we could only give it to very high-risk babies. So that is the first strategy, antibodies for babies. And the second is a vaccine for pregnant women. If you give mothers a vaccine during their pregnancy, the bodies of the mothers will make antibodies and will give the antibodies to the babies. And the third strategy would be vaccines for older adults. Very recently, not only the new antibodies, but also a vaccine for pregnant women and for older adults has been approved. And the vaccines, some of the vaccines are starting to get implemented in several immunization programs around the world. So this is all very exciting because we expect a lot of changes in this field in the next few years. Well, this brings me to the second part of our webinar, which is based on the webinar for professionals from last November. In this webinar, Professor Philip Lemay shares findings from a recent study in which he and other researchers looked at the global spread of RSV and also specifically what drives this spread. And from the title of the presentation, you might have guessed, airplanes play a very important role. The work of Professor Lemay, which he talked about in this webinar, is on virus evolution and molecular epidemiology. These are very difficult words, but what they actually mean is that researchers try to understand how a virus spreads on a larger scale. So not from one person to the next, but also on a global scale. So when you look at this picture you see on the left, you see a group of people, and some of those people are infected with RSV. You see this small virus particle in purple. When researchers take the virus that is sampled from that patient and look at its genetic profile, which is nothing more than looking at the genes, they can find out more about the evolution of that particular virus. And that way, they will find out more about how the virus spread. And with this type of research, there are actually 4 questions that the researchers try to address. The first questions are actually about the introduction of the virus. So how does a virus enter a population? Where does it come from? The question is also, does it come from just one spot, like you see in the picture here? So it's introduced from a certain area into a group of people by infecting one person, and that person goes on to infect other people. Or might it be that there are several introductions in a population, as you see in this picture? So the virus is introduced from 2 separate places and then goes on to spread in that group of patients. So 2 questions about introductions. Where are they from and how many are there? And the next question is about the dynamics of transmission. So how exactly does the virus spread through a population? Is it, for instance, from one person to several persons, as you see in the picture on the left? So you see one person is infected and they go on to infect several other people? Or is it the case that just one person infects one other person and then they go on to infect one person and so forth? Another question about transmission would be, is it spread through children in schools or mostly in households? And then the third topic would be about the pattern of how the virus behaves. So is the pattern the same for each outbreak? So every time we see an RSV outbreak, does the spread move in exactly the same way? And if so, can we anticipate on that? Or might it be that it's not repeatable and that it changes with every outbreak? So all of these questions belong to the field of virus evolution and molecular epidemiology. So in the work of Professor Lemay, researchers tried to solve at least some of those questions. And one of those studies is called the INFORM study. And this is a global study that is still ongoing. It started in 2017. And the data I will show you here that Professor Lemay talked about are all collected between 2017 and 2020. So the data were collected right before the COVID-19 pandemic. The data included are from 19 hospitals in 17 countries, and they involve RSV virus samples taken from children under the age of 5. And the goals of the investigators were to investigate the genetic profile of RSV. So looking at the genes, I will show you in the next slide what that means. And also to look at differences in those profiles, both in time and space. So how did they do this? Well, every hospital sent between 50 and 100 respiratory samples. So these were all swabs of children with RSV that they sent to the researchers. And the researchers then performed genome sequencing. What is genome sequencing? Maybe you've heard of it. It means that they take the genetic material of the RSV virus, this is called RNA, and they make a readout of it. So that way they end up with a complete genetic profile of the virus. So on the right, you can see a picture of an RSV virus particle. And as you can see, there's RNA inside it. And when they make a complete readout, they will see what you see on the bottom. So they will see what genes are there and what changes are present in the genes. And the changes are also called mutations. And by looking at the complete genetic profile of each virus that they sampled, they can compare them and see how they are different and how they are similar. But why would they do that? Well, with this information, the researchers are able to look at how these viruses are related. And what they do is they create a so-called phylogenetic tree. You can just forget that word, but it is just a way of showing how related the viruses are. Maybe you've seen a family tree before. this is more or less the same. So by putting all the genetic profiles in the tree, you can see how related the RSV viruses are. So you can see this by looking at how far apart the branches are. So now for the results. These two phylogenetic trees show the relatedness of the two RSV types, RSV-A and RSV-B, which are sampled from all over the world. So these data are collected during the INFORM study, and they also use some additional data from a huge database. And together, you can just see how these virus types are related and how different they are. And you can see by the colors for which continents they were sampled. And as you can see, viruses that are found in, for instance, Europe are in general less related to viruses in, for instance, Africa. But there are also some similarities. So certain viruses occur in different continents. The researchers found that during an RSV outbreak, there are likely many independent introductions. So like I showed you in the beginning, but the researchers are not entirely clear yet on where they all come from exactly. And then the next thing the researchers did was also look at the shape of the tree, because the shape of the tree says something about how a virus evolves. So the shape of the tree will illustrate if the virus evolves in a neutral way. And when we say it evolves in a neutral way, it means it is completely random which RSV virus strains go on and which stop to exist, as you can see from the tree, which has very evenly dispersed branches, the tree on the left side. However, what the researchers found when they looked at their data is that there is selective pressure. And what this means is that certain genetic profiles are more successful and are more able to go on while others don't. And this is why the tree is shaped like the picture on the right. So the genetic profiles of the successful RSV viruses were found to mostly contain certain mutations, which is changes in their genetic profiles. And most of these changes are in the ability of the virus to attach to airway cells. And I think this makes sense, right? Because if the virus has mutations making it better able to attach to airway cells, it is more likely that that specific virus strain will be more successful and will be able to spread more easily. And then finally, I know you're all waiting for the air travel to come in. Finally, the researchers looked at factors that influence the spread of RSV around the globe, and they found that air travel was the most important factor driving the spread of RSV. And very interestingly, this is very similar to what we already knew of the spread of seasonal influenza and also of SARS-CoV-2. The information on the spread of RSV is, however, very important. So first of all, researchers will have a better idea of how outbreaks of RSV come about or how to reconstruct them when they happen. But also, they will offer very valuable information to predict how certain RSV viruses, for instance, with certain mutations, might spread. Now, why is this important? Why do we need to know how that might occur? Well, when you think back about the new vaccines and antibodies, maybe it will become more clear because, for instance, if we would have RSV viruses that become resistant to the vaccines or the antibodies, then we should be able to know how they might spread across the globe so that we can anticipate on it, maybe do something about it, predict how they will spread. So what we have learned about the spread of RSV from these studies is very important in light of the new prevention products. And with this, I would like to conclude my presentation. So a short recap. What have we learned about the spread of RSV across the globe. We've learned that, like with other viruses, air travel is a very important driver. We can use this information to predict how RSV will spread. And this is, I cannot stress it enough, this is very important in view of the new vaccines and antibodies. And especially, like I said, for instance, if resistant strains would suddenly emerge, we would be better able to predict the spread and maybe do something about it. So on the eve of this new era of prevention products, I think it is ever so important to have this knowledge and to have talked about this. With that, I would like to thank you very much for your attention. And I give the mic back to Leila and invite you to ask your questions. Thanks.
Thanks. Thanks, Lieke. Thank you very much. I really enjoyed the talk because I also I was at the webinar given by Dr. Lemay, and I found it very difficult to follow, to be honest, because that was very difficult webinar. and I really admire how you have made it so easy, understandable today for our let's say general public. So thanks a lot for that. I am having some issues with my laptop, so I'm now working on my mobile, so I'm not sure if I can see all the questions coming in. So help me there if you see any questions. But maybe I can start with one question, Lieke, because indeed what you just said about the new vaccines coming, right? New therapies and new interventions coming to the market. And so as far as I know, at this moment, as far as we know, we have a new monoclonal antibody, we have new vaccines coming, but these are all for high income countries at this moment, right? And I don't see it now going to low middle income countries in near future. So how would it, if you see all this travel, you know, how RSV travels by plane and so, how would it affect the spread of the virus in, let's say, in the high income countries where we hope to have it have it lower, like to have the infection lower by the vaccines?
Sorry, Leila, could you maybe repeat the final part of your question? I couldn't quite hear, sorry.
Oh, sorry for that. So I was just saying, you know, if the new interventions that are coming to the markets, if it's only being delivered in certain countries, but not, let's say, in low middle income countries, how would it affect, you know, the efficacy, let's say, of those interventions? Because, you know, RSV travels by airplane, as you say, so in many countries there will be no intervention.
Yeah, that's a great question, Leila. And I don't have a very good answer yet, I'm afraid. So what I found very striking is to see that airplane travel plays such an important role, because I always thought that the spread of RSV is mostly through children. And I think, although children also travel by airplane, I think it is mostly adults who make up the bulk of the ones that travel through the air. So in order to answer your question, how will it impact the spread? The fact that we only have these prevention products in the higher income countries, I can only speculate that in those countries, we still have to see what the prevention products do for circulation of the virus, because to be quite honest, we don't quite know that yet. We know that the prevention products are aimed at protecting the vulnerable ones of becoming severely ill with RSV, but the main aim will not be to prevent infection altogether. So I also find it difficult to predict whether or not there will be much less asymptomatic, for instance, spread of RSV. And asymptomatic means that there are persons who don't have any symptoms of an infection, but who are still contagious and able to spread the virus. So yeah, I think we will have to see what happens there. And that is another thing that I was also wondering about, which also pertains to this question, is if air travel plays such an important role, then is it the case that just one person on that plane is infected with RSV and goes off the plane and then infects other people, and thereby introducing the virus in that population, like I showed in one of the pictures? Or is it the case that several persons on the airplane become infected because of this person who is traveling with the infection? Because that might also have different outcomes. So I think there's still a lot that we don't know regarding that question, Leila.
No, that's true, and that makes it actually very interesting, right? This whole study. So I'm not sure. Like, can you see if there are any questions in the chat?
Yeah, I can see there's one question by Merel Punt, and she asks, she says, my question is about researchers as well. What are other current research topics related to RSV? So this is a very important question. Thanks, Merel. I think one of the things is what we already touched upon. So what will it mean when the prevention products are introduced? So for instance, like Leila already said, will it also affect the spread of RSV? So will the fact that we use these products to prevent children from becoming ill also prevent them from spreading the infection? And we'll have to see about that. And another thing that researchers are very curious about is to see what will happen when these prevention products are used. Will there be, for instance, resistance in certain virus strains? So will the RSV virus be able to circumvent sort of the immune system so that the prevention products will no longer be effective? This is something that we will have to see what happens. So those are still important research topics. And another one that is also very interesting is the one that we talked about in the previous webinar for the general public. And that one was about asthma. So the risk of asthma is increased if you experience an RSV infection as a young infant. So I think we'll also have to see what those prevention products do for the long-term effects of having an RSV infection. There are all sorts of other research topics around RSV, but those are very important ones that come to mind.
Yeah, and I think also, Leke, what you showed us about the INFORM study, that is also one of the studies where we actually are, indeed, since 2017, are looking at the mutations in the in the genome of the virus. So that is also being monitored all the time. So it's also going on in the coming, let's say, 4 or 5 years, still to see how the mutations are developing in the virus, and also how it affects maybe the virus composition, and also maybe the, let's say, the binding sites for, for example, for monoclonal antibodies and so. So it's also a very important part of the research that is ongoing.
Yeah. I think Merel has another question. She asks several questions. So she asks about the vaccine. She says, When will we know more about whether or not we will get the vaccine or it will be used? That's also a very interesting question. I do not know about all the specific countries. I know that some countries have already started implementing vaccination for RSV in their immunization programs. And to be specific for the Netherlands, we expect the Health Council, so to say, to come up with a recommendation in mid-February. So then they will recommend to the government whether or not the RSV vaccines should be implemented in the national immunization programs. So it is around that time that we expect more to be known. But like I said, for each country, this will be different. And then there's another question that Merel has around about the vaccines. And she says, when we talk about a vaccine that is protective, what does it mean? And that's a very good question. I don't think I've explained that well enough. So what it means is that when you give these healthy babies a vaccine, their body will make antibodies to protect them from becoming severely ill with RSV. The vaccine is very effective, so the chances of those babies becoming severely ill are greatly reduced, roughly around 80%. So that is very high efficacy. And we think that, for instance, when you look at the antibodies, that they protect the children for a long period of time, so around 5 to 6 months. And if you recall, the antibodies that we have had for several decades, like I mentioned before, the ones that we have to give the babies every month, they will only protect the babies for a month. So that is a huge difference and makes it very an attractive option to give to babies. Let's see if there's any other questions. I see one more by Merel. She says, are there any known side effects of the vaccine? That's also a very good question. And that is, of course, something that the health councils of every country will take into account. So these vaccines are very safe. They've very extensively been tested, and they actually have similar side effects to other childhood vaccines. So some local possible irritation, also sometimes some increased body temperature, but no other side effects that are specific for this RSV vaccine. So it is a very safe vaccine. Thanks for all those questions, Merel. Let's see if I can find any other questions.
I don't think that I see any other questions as far as I can see, Rika.
No, I think so either.
I thought I saw a message from Liz, but I'm not sure if she had any questions. No.
Yeah.
Okay.
Yeah. Yeah, so there's one thing that I was still wondering, Leila, if that's okay with you.
Sure.
I noticed a lot of participants from other countries. I was just wondering, because I don't know about all the other countries or in what stage of implementation they are or are not. Is there anyone who might comment on that? Well, maybe they've fled.
Yeah. So it could be that. So we know, for example, that in Spain, that it has already been provided, and there was also a very high coverage. So a lot of children have been vaccinated for this, and let's say immunized for this season. But I'm not sure which other. I think US also, in the US, it has also been provided. But not sure about other countries, to be honest. Okay, Rika, so do you agree that we can close the webinar, or?
Yes,
Yeah?
thanks
Okay.
very much.
Thank you very much, and also thanks everyone for joining us, and also for the questions. And this webinar has been recorded, and it will be in the coming week. It will be also, the replay will be available on RSV website, so you can watch it back if you want, or share it with others. That would be great. Thank you again, and have a great day, and see you soon at the next webinar. Thank you. Bye.